In class, we've been working on verifying trigonometric identities. I always like to take a moment just to simplify a trigonometric expression. It's the same set of skills, and in one way simpler because you only have one thing, but in my opinion, in one way it's harder is I don't know where this is going. When I'm verifying an identity, I have an equation and it tells me that I'm going to turn one side into another side. This one I'm just supposed to simplify, make it look easier than it does now, so I'm kind of just on my own in a way. All right, so I'm going to start this one with the common wisdom, that good advice that if I don't see what else to do, I can rewrite everything in terms of sine and cosine. I have a feeling some of y'all have already seen an easier way to go about this problem, and we'll talk about that in a moment. But just in case maybe I was having a bad day and I didn't know what to do in that one-step way to solve this one, I just did this. Well, now I think to distribute. And I get cosine squared theta plus, well, and the cosines cancel when I distribute there, so I just get sine squared, and I realize that this is equal to 1. Now, whenever I'm simplifying a trig expression, I do like to help my reader out, and I'm going to state what I used over here. This was a quotient identity. And here I distributed. And to get down here, I used the Pythagorean identity, and I think we will all agree that I can't get any simpler than this, right? This is equal to 1. Now, I wish we were in a classroom together right now because I'd ask you all, if anyone saw an easier way to do this. And there's a almost one-step solution to this. And so I start with that same expression. And in parentheses here, if I'm really thinking and I really know my identities well, right? See, right away I know cosine squared plus sine squared is equal to 1, and I pointed at that in the wrong order, but you know what I'm saying. I use a Pythagorean identity to get from here to here anyway. Well, I know there's more than one of these. If I divide everything by tangent, I get tangent squared, if I divide everything by cosine squared, I get tangent squared plus 1 is secant squared. So right here in parentheses, I have this expression, and so just using one Pythagorean identity, I could write this as cosine squared theta times secant squared theta. That's a Pythagorean identity. And then cosine and secant are reciprocals of each other, so if I multiply cosine squared by secant squared, I have to get 1, and that's a reciprocal identity. And so if I see that right away, I can use that Pythagorean identity more quickly, and I just get that this is 1. But even if I'm not having the best of days and I think to do this, everything works out just fine.